Thanks, David. Hi, everyone. My name is Kate Park, and I'm here to talk about the data engine, which is the process by which we improve our neural networks via data. We're going to show you how we deterministically solve interventions via data and walk you through the life of this particular clip. In this scenario, autopilot is approaching a turn and incorrectly predicts that crossing vehicle as stopped for traffic, and thus a vehicle that we would slow down for. In reality, there's nobody in the car. It's just awkwardly parked. We've built this tooling to identify the mispredictions, correct the label, and categorize this clip into an evaluation set. This particular clip happens to be one of 126 that we've diagnosed as challenging parked cars at turns. Because of this infra, we can curate this evaluation set without any engineering resources custom to this particular challenge case. To actually solve that challenge case requires mining thousands of examples like it, and it's something Tesla can trivially do. We simply use our data sourcing infra, request data, and use the tooling shown previously to correct the labels. By surgically targeting the mispredictions of the current model, we're only adding the most valuable examples to our training set. We surgically fix 13,900 clips, and because those were examples where the current model struggles, we don't even need to change the model architecture. A simple weight update with this new valuable data is enough to solve the challenge case. So you see, we no longer predict that crossing vehicle as stopped, as shown in orange, but parked, as shown in red. In academia, we often see that people keep data constant, but at Tesla, it's very much the opposite. We see time and again that data is one of the best, if not the most deterministic lever to solving these interventions. We just showed you the data engine loop for one challenge case, namely these parked cars at turns. But there are many challenge cases even for one signal of vehicle movement. We apply this data engine loop to every single challenge case we've diagnosed, whether it's buses, curvy roads, stopped vehicles, parking lots. And we don't just add data once, we do this again and again to perfect the semantic. In fact, this year, we updated our vehicle movement signal 5 times, and with every weight update trained on the new data, we push our vehicle movement accuracy up and up. This data engine framework applies to all our signals, whether they're 3D, multicam video, whether the data is human-labeled, auto-labeled, or simulated, whether it's an offline model or an online model. And Tesla's able to do this at scale because of the fleet advantage, the infra that our Eng team has built, and the labeling resources that feed our networks. To train on all this data, we need a massive amount of compute, so I'll hand it off to Pete and Ganesh to talk about the Dojo supercomputing platform. Thank you.
Thank you, Katie.